Hello, I'm Zalara, and today I'm gonna share with you guys about dwell time, what it is and why we need it. But before we get into dwell time, let's talk about something that you might be more familiar with, and it's about frame rate. Frame rate is the frequency at which consecutive processes are being updated. Frame rate value might be continuously changing depending on the platform, device capabilities, and the usage of the computer. If we are doing an expensive computation at a certain frame, then it will be likely for the next frame to wait longer to process. Therefore, the game might not achieve our preferred target frame rate. On the contrary, if we're doing a lighter computation at a certain frame, then the next frame will wait shorter to process. Therefore, the game can even have a higher frame rate. The shorter the wait time for the next frame update, meaning that the game updates more frequently and in result, will display more smoothly. So let's get to the point. Why does it matter in our game program? In our game, we most likely want our object movement to be as consistent as possible. For example, when we build a car movement, if it moves at 50 km per hour, then we want to make sure it always runs at the same speed, be it at 30 frames per second, 35 per second, 50 frames per second, 60 frames per second, or whatever our frame rate is. We might notice in some older games, the most common target frame rate was locked at 30 frames per second. And when our computer is at a lower frame rate, 15 FPS for example, then the game will run at slower speed. In other words, the game is frame rate dependent. However, there is another option to make the game to be frame rate independent. This means that no matter how much our frame rate is, the movement will be processed at the same speed, and this can be done by utilizing dwell time. But what is dwell time? In Unity, we can get the current elapsed time in seconds since the start of the application by calling time.time. We can try to debug the time value of each frame using the update method, since the update method is called each frame. If we try to debug the time value from a certain frame and compare it to the value in the next frame, then we'll notice that the value is now higher. If we subtract the current time value with the time value of the previous frame, then we will get the dwell time between those two frames. So dwell time is the interval in seconds from the last frame to the current one. It is already handled by Unity, therefore it's read-only and it's ready for us to use. You can try to print the two interval values between the one we manually calculated and the one that is provided by Unity using time.delta-time. And we'll see that both of them actually print the same value. The small difference is that the time.delta-time returns a rounded value. The delta time value might vary on each frame since it depends on our frame rate. For example, when our current frame rate is 47 frames per second, then the delta time would be 1 divided by 47 equaling approximately 0.02127. And when our current frame rate is 59 frames per second, then the delta time would be 1 divided by 59, equaling approximately 0.016949. Using the delta time value, we can multiply it with the actual speed to apply the delta movement, but it will be applied separately frame by frame. To make it clear, let's visualize this. Let's say we want our character to move 2 meters forward. We can move it by adding a constant velocity value, for example 0.05 on each frame. Therefore, the character will arrive in 40 frames. But the problem is, if our frame rate is 40 frames per second, then it will arrive in 1 second. If our frame rate is 50 frames per second, then it will arrive faster in 0.8 seconds. If our frame rate is 60 frames per second, then it will arrive even faster in 0.667 seconds. Now, let's try utilizing delta time. Let's say we want our character to move at 2 meters per second, so no matter how much the frame rate is, it should arrive in 1 second. So, to apply the frame by frame movement, we have to separate the delta movement, which is 2 meters, into smaller chunks that are called per frame. In this case, all that we need to do is to multiply the delta movement, or the 2 meters value, with the delta time value of the current frame. This way, no matter how many frames have elapsed with each of their different delta time, we manage to move 2 meters in 1 second. One more important thing to note is that the lower the frame rate, the higher the delta position would be, resulting in a visually less smooth movement, although with a correct speed. But in the end, it is more important to make sure that our game is running at a consistent speed. And that's all for delta time. I hope you guys enjoy it. In the next video, we will cover fixed delta time, what it is and why we need it. So be sure to subscribe because it means a lot, and check out for my next video. Thank you very much and see you guys in the next video.